up a problem to answer when you do multiple percent changes. So we have a toy that's marked up 80% by the store. So that's the first thing that happens, right? Then after a few months, they have a bunch left over. They slash the prices. They put it on sale. And then for, let's say, 50% off. So we'll just do two for now. A markup and then a markdown. So let's the key to solving these problems and many percent change problems is to just pick a starting point. Pick a really convenient number to call the price of this toy at the very beginning. When you're dealing with percentages, what's a really convenient number to use? 100. So let's say that the toy starts at $100. Okay, so this is you just make that up. This is our secret weapon for percent change problems that involve markups and markdowns. Just start with 100. And if it doesn't have to do with money, if it has to do with people and the amount of people that are changing, start with 100 people, right? It really can help when you're doing percentages. All right, so if we mark it up 80%, so the first thing that happens is that we have to increase this price by 80%. How do you increase a number by 80%? Times it by 0.8 and then add it to the original price, right? So I could do the original price plus 0.8 of the original price, or you can do the original price times 1.8. Those will get you the same thing. Okay, so that should come out to $180. Okay. So the wholesale price of the toy is $100. The toy store is selling it for $180. All right, but then, after a few months, Christmas has passed, there's a little less demand, they want to get rid of these things, they're going to mark it down 50%. So 50% of 180, $90. So we just do the 0.5 times 180, $90 is the final sale price. Right? So now what we want to do is we want to compare the original price, the $100, to what they're selling it for. Right? So it started at $100 and they're selling it for $90. It's a 10% decrease, right? So the store is selling this for a 10% loss. So then my conclusion is that I would say, well, if I want percent change in price, you do the amount of change compared to the original amount. $100 to $90, what's the amount of change there? $10, yeah. So $10 was how much the price changed compared to the original $100, and 10 over 100 is 10%. This is where the magic of choosing the $100 at the beginning comes in, is when you do this final analysis. It just makes it really easy to take this last percentage. So this was a 10% loss, right? Because we know it went down from 100 to 90. So the store is taking a 10% loss just to get rid of these things. Thanks. So in this formula, that capital P is the amount you're setting aside regularly. So if you're going to try to save $200 a month, that capital P would be a 200. Little p, that's called your periodic interest rate, which is your interest rate divided by the number of times you're making this payment per year, which is often 12, right? If you're saving monthly, this would be a 12. This is the number of deposits per year. R divided by the number of deposits per year. And then capital T is the total number of deposits, right? So if you were going to make monthly deposits into this account for 3 years, capital T would be 36. Monthly for 3 years would be 36 total deposits. All right, so you asked me to actually do some problems. We'll do the study guide problems. I just want to like try to make this little cheat sheet before we start. Okay, so those are all the formulas that deal with saving money, right? So you're gonna, if you have a problem that deals with saving money, you're gonna have to pick from these 4 formulas. Easy to pick out simple interest because the word simple interest will be in the problem. For compound interest, that's one chunk of money, and you should look for the word continuously or a number of times to compound per year. And this one's also easy to pick out because this is the one where you save a little bit at a time. Little p is called a periodic interest rate. Periodic interest rate, which is your interest rate, R, right, divided by the number of deposits per year. Yep. Yes, you can bring this sheet from your packet to the test with you. Yeah, you can write on this, make notes to yourself about what these things represent. So these are all the formulas for saving money, 4 different formulas. And hopefully you've got some keywords now to pick out which formula to use in which situation. All right, and then the next thing that we had dealt with in terms of finances was debt. Okay, so we have 2 different kinds. 2 different kinds. We have credit card, and we have amortization. So credit card, I mean, that's pretty self-explanatory what the word credit card means. Amortization is when you take out a loan, a fixed loan. Like I'm going to borrow $20,000 and then you have to pay back a regular amount every month, a constant amount every month for a certain amount of time. So this is like a car loan or a mortgage loan, basically. All right, so for a credit card, there's 4 formulas. You need the periodic interest rate, the average daily balance, how to calculate the finance charge, and then how to calculate the next statement balance. I think that these are pretty self-explanatory on the sheet. Do you need me to like, we'll do the problem. We'll do a problem and go over it, but I don't think I need to write them all down because the keyword thing isn't as much an issue in here. Like you'll know this is a credit card problem because it'll say credit card. Okay, and then for amortization, this is a loan where you're calculating your monthly payment. So the formula is M equals, right? M for monthly payment. And it's going to be capital P, which is the amount you're borrowing, times R over 12 times 1 plus R over 12 to the T divided by 1 plus R over 12 to the T minus 1. And the only thing you have to be careful with here is the order of operations and plugging it into your calculator. But you'll know when to use this formula because the question will be talking about a loan with regular monthly payments. So a keyword would be monthly payments. for a loan. Or the word amortization. Yeah. Oh, yeah. Repaid, maybe? Or just paid? Paid over T monthly payments. Yeah. All right, so that covers all the financial formulas and when to use them. So I think that what we should do is, as a class, answer some of these questions that use the financial formulas. Do them together. Okay, so here's the first one. Norm is saving up for his daughter's college tuition. So it's a savings problem, right? So we're going to be using one of our 4 savings formulas. Saving. So we now have narrowed it down to 4 formulas. He plans to save $150 per month. So he's setting little bits of money aside over time. So that's going to be the fixed annuity formula. So we just write down that formula. F equals P times 1 plus little p to the T minus 1 over little p. So within the first sentence and a half, I've decided on a formula. Now I'm just going to have to plug in all the stuff that they tell me and solve for the thing that they don't tell me. Okay, so 10 years. All right, good. $150 per month. He's going to earn 7% annual interest compounded monthly. All right, so he's setting his money aside every month, and it's earning 7% annual interest. Right? So little p, right? So let's just along the side here, I'm going to fill in what I know. P is the amount of money that you're depositing regularly, so this is $150. Little p is called your periodic interest rate, and it's your annual interest rate divided by the number of times you compound, or the number of times you make this deposit. So how many times per year am I depositing $150? 12. Right, and sorry, my annual interest rate is 7%, so I'm going to put in a 7, a 0.07. Right, 7. You always use interest rates as a decimal in these formulas. So 0.07 divided by 12. .00583. So now you can either store this number in your calculator and use it exactly if you want to be really exact. But I'm not going to, on the test, I'm not going to take off for being off by a couple of dollars for rounding. So if storing the numbers is like just one more thing you have to learn for this test, don't bother, right? Just type this number in every time you need it. Let's say let's say 5 until the end, right? And at the very last step, you round to the nearest penny, which should be 2 decimals. Okay, and so one more letter in here is capital T, right? Capital T is the number of deposits we're going to make total. So we're making 12 per year for 10 years. So T would be 120. 12 per year times 10 years is 120 total deposits. So then we just plug in all the stuff, right? How much money will be in the account when his daughter begins college? That's the future value. So we're going to be looking for F here. P is going to be 150 times 1 plus 0.00583 to the 120 minus 1 over 0.00583. So now we just have to simplify this expression on the right, being careful to follow the order of operations. All right, so I have 1 plus 0.00583 because that's in parentheses, so I'm going to do that addition first. Next thing I should do is exponents. So I raise to the 120. Then I'm going to subtract 1, and then I'm going to divide by 0.00583. 173.04. So this is 150 times 173.04671. So then I'm just going to take that number and multiply by 150. Oops. $25,957.01. Okay. This number might be slightly off from the answer that I have at the back of the packet because I rounded 0.00583. $5 off, yeah. Yeah, I mean, over the course of 10 years, $5. The decimals do make a difference, which is why I was teaching you to store the numbers. But you know, I'm more interested in the process than the exact accuracy. This is a little off because I rounded the 0.07 divided by 12. Right? Any questions on this one? All right. So Norm's daughter decides that she's not going to need that much money to go to college because she's going to attend GCC, and she figures she needs about $15,000 to cover her bills. So instead of saving $150 per month, how much does Norm need to save so that there will be $15,000 in the account? So we're going to use the same formula because this is the exact same scenario. He's setting aside regular amounts of money monthly, but this time I'm given the future value, right? I want the future value to be 15,000. What is the amount that I need to set aside? So I'm going to write down my formula. F equals P times 1 plus little p, oops, the T minus 1 over little p. Okay, so now this time I'm going to replace F with a 15,000. P is what I want to know. What's my payment amount? And this number in parentheses I actually calculated a little while ago. It was 173.04. You can do it again, but it comes out to 173.04671. After you plug in your little p and your capital T and do that all out. So then you just have to divide both sides by that number. Those cancel, and we're going to get capital P is 86.68. Which again might be slightly off from the answers that I have. The answer that I gave, it was 86.66, right? So this is off by 2 pennies. Why? I rounded. This number 173.04671 had more decimals on it. So when I used a rounded number, it made my final answer be a little bit off. Not the worst thing. It's fine. All right, I'm going to skip the snowflake problem so that we can stick with the finance stuff, and then we'll come back and do the snowflakes. Oh, okay, we'll do this percentage problem, even though it's not really finance. All right, so the smoking rate among 10th graders was 12.1% in 2005, and it jumped 45% in 2006. So what percentage of 10th graders smoked in 2006? You might be tempted to just add those two percentages together, but you can't add percentages, right? So the key when you're working with percentage problems is to just let there be 100 things, right? So in this case, they're going to be, let's just pretend there are 100 10th graders in the world, right? Let's say there's 100 of them. So there are 100 10th graders, right? If 12.1% of them smoke, how many 10th graders is that? 12.1, yeah, about 12. I mean, that doesn't really make any sense, but suspend disbelief, right? Okay, so 12.1 10th graders smoked in 2005, okay? Because 12.1% of 100 is 12.1 10th graders. So now, if we jump by 45%, we need to increase 12.1 people, 12.1 smoking 10th graders by 45%. How do you increase a number by 45%? Multiply by 1.45, or you can just multiply by 0.45, but then you have to remember to add it to the 12.1. So I say, okay, well, I start with 12.1. To increase by 45%, I multiply by 1.45. Right? The 1 is because we still have 100% of those 12.1 10th graders as smokers, and then we're going to add another 45% to that. All right, so 12.1 times 1.45, 17.545. So in 2006, there's 17.5-ish 10th graders who smoke, right? So this is 10th graders, right? Those are my units, 10th graders who smoke. So what percentage of 10th graders smoke now? 17.5-ish, right? Because there are 100 10th graders. 17.545 of them smoke. That is 17.545 out of 100, which is 17.545%. So that's a big, really helpful thing to do when you're dealing with percentage problems. If you have an unknown quantity, right, maybe just let it be 100, and then increase and decrease it by whatever percentages. All right, so here's another percent change problem. Stock market crashed in 1987, and the Dow fell by 22.6%, and it landed at 1738.42. What was it before the crash? Okay, so that would be a really that would be a natural instinct and a thing that you might easily jump to doing. Take 22.6% of 1738. But we didn't take 22.6% of 1738. We took 22.6% of the original, and it landed here. This is what it equaled. So what they're asking me was the value before, and the value before is what you took 22.6% of. So if we let the value before be x, right? Then I'm going to decrease x by 22.6%, and I'm going to get 1738.42. What should I multiply by to decrease something by 22.6%? Okay, so if I multiply by 0.226, what I get is how much I'm going to take away, right? Because I lost that much. So if I multiply by 0.226, I have to take, that is what I subtract from the original. Reverse it. 1 minus 0.226. Right, so if I'm losing 22.6%, right? So I'm starting with 100%, and I'm going to lose 22.6%, which means I'm keeping how much? 77.4%. I only get to keep 77.4% of the previous value because 22.6% is going away. So if I multiply by 0.774, multiply the original stock market value by 0.774, I should land at the new stock market reduced value. There are other ways to set this up, right? Right? Similarly, I could say, well, take the previous price, previous Dow average, and subtract 22.6% of it, and that would give you 1738.42. And then you just have to combine like terms, right? 1x minus 0.226x gives you 0.774x. So all I have to do is 1738.42 divided by 0.774. $22.46. Okay, so the 0.774 is related to the percentage 77.4%. So if and I got that by saying I'm losing 22.6% of the value, right? So start with 100%, take away 22.6%, and you're left with 77.4%. Okay, let's look at the simple interest problem. You are borrowing $650 for 3 years. Simple interest, so we automatically know what formula to use, right? At 5.49% APR. So I'm just going to write down my simple interest formula. Future value is equal to present value times 1 plus RT. R is your interest rate written as a decimal. T is time. Okay, how much is the total you must pay back? That's the future value, right? So you have to pay the future value. You're borrowing $650. That's the present value. Today, they give you $650 if you pay back more than that in the future. So we put in 650 for P. Okay, so my interest rate is 5.49%. So what do I plug in for R? 0.0549. Just have to put it in as a decimal. 0.0549. And then time, in this case, is 3 years. And Mike, you said 1.0549? The 1 is already accounted for in the formula. Yeah, okay. All right, so now we just follow the order of operations. So I have to do the multiplication first. 0.0549 times 3, and add 1, then multiply by 650. So I get 757.56. Oh, 6. Oh, yeah. Thank you. Okay with simple interest? Okay. Okay, so now I'm investing $4,200 for 5 years at 7% compounded monthly. So this is one chunk, right? I'm putting one chunk of money in. So I narrow my formula and I see the word compounded monthly. Right? So one chunk of money, and I don't see simple interest. I've narrowed it down to 2 formulas because there's no words simple interest in there. So it's got to be the compounded n times per year or compounded continuously. It's compounded monthly, then it's a finite number of compoundings per year, and I use my compound interest formula. Which is that. All right, so 4,200 is my investment, so that's my principal or my present value. And I want to know how much I will have, so that's the future value after 5 years. All right, so I plug in all the numbers I know. 4,200 goes in for my present value. 1 plus, my interest rate is 7%, so I should plug in what, Allie? 0.07, good. Divided by n, which is the number of compoundings per year, which should be what in this case? 12, because I'm compounding monthly. That's 12 times per year. So I put in a 12 for n, and then I put in a 12 for n up here, and t is 5 years. All right, so now I just have to do this all out, following the order of operations. So I'm going to start by simplifying what's in the parentheses. So, and within the parentheses, I have to do the division first. So I do 0.07 divided by 12. Then I add 1 to it. Then I have a multiplication and an exponent. So I'm going to do the exponent first. So I have to raise that number to the 12 times 5, or just the 60th. Then multiply by 4,200. And I get 5954.03. So does everyone see, can everyone pick out the words in this problem that tells you to use this formula? What? Compounded monthly. Yeah, that's the main, that's a big key word. Yep. And the fact that it's one chunk of money, right? So the next one's compound, yeah, question? That's okay. 12 times 5. That's n times t. Okay, so in the next one, we're compounding daily. You can invest some money today that's going to be earn 12% interest compounded daily. How much do you need to invest today? So that would be one lump sum investment, right? So that you have 1,000 1 year from now. So this is going to be a future value, right? How much do you need to invest today? That's what's the present value? So I write down, here's my formula that I'm going to use, same formula, but this time I'm going to make my future value 1,000. Present value I don't know, and then plug in all the other stuff. 1 plus 0.07 divided by 12. Oh, sorry, it's 12% this time. And it's compounded daily, 0.12. So what's n going to be? 365. The n times t, so that's 365 times 1 year. Okay, so this becomes 1,000. So I'm just going to simplify the right-hand side here, equals p times. And now I'm just going to simplify all of this arithmetic. So in the parentheses, I'm going to do 0.12 divided by 365, then add 1, then raise it to the 365 times 1, which is 365, and I get 1.12747. Say that again? Oh, yes, because 365 times 1 is 365. So then to find out what P is, what the present value is, what do I do? Just divide both sides by this 1.12747. All right, so now to do the division, 1,000 divided by 1.12747, 886.94. What are you getting? Yeah. You're doing 0.12 divided by 365. Okay, hang on. Good thing to point out. So my calculator is giving this answer in scientific notation. That e to the negative 4 means move the decimal place 4 to the left. So your calculator might have given you 0.000328767 instead of scientific notation. They're equivalent. Okay, so that covers all the savings questions. So we've got one question here about a loan. We have a car loan. We want to finance $9,500. So it might be that the car costs more than that and we put some money down, or maybe we're financing the whole price, which is $9,500. I don't know. But we're financing $9,500 over 36 months or 3 years at 5% compounded monthly. Find the monthly payments for the loan. So the formula for monthly payments starts with an M, right, for monthly payment. M equals P, which is the amount of money you're borrowing, times R over 12 times 1 plus R over 12 to the T divided by 1 plus R over 12 to the T minus 1. So, I mean, it looks ugly, but that's why we have calculators. Make this easier. All right, so P is our loan amount. Right, so I'm looking for monthly payment. I'm trying to figure out what M is. So I have to be able to fill in every other letter with a number. So I replace P with 9,500. And then R is 5. 5%. So little r in my formula, I should put in what? 0.05. So I've got 0.05 over 12 times 1 plus 0.05 over 12 to the t, which is the number of payments, which is 36. We're making monthly payments for 36 months, so this is 36 payments. And then I'm going to divide all that by 1 plus 0.05 over 12 to the 36 minus 1. Okay, so this is a problem where it is really handy to store a number, but again, you don't have to. We could do this in multiple steps. So if I do 0.05 divided by 12, I get 0.0041666666. So if I round that to say 5 decimal places, I get 0.00417. We'll use that. So this is 9,500 times 0.00417 times 1 plus that 0.00417. So 1.00417 to the 36 divided by 1 plus that same number again. So I have 1.00417 to the 36 minus 1. Okay, so now working within the big square brackets, I should follow the order of operations. Do the top and the bottom separately and then divide. All right, so working on the top of that fraction, I should do the exponent first. So I have 1.00417 raised to the 36. Then I multiply that by 0.00417. I get 0.00484. And then in the denominator, I have 1.00417 to the 36 minus 1. Oops. So I get 0.16161. So now I'm going to do the stuff in the brackets. 0.00484 divided by 0.16161, and then multiply by 9,500. So I get 284.51. And my answer to number 9 was 284.72. So it's a little bit different because I rounded a lot of my numbers. If you stored the numbers and didn't do any rounding, you'd come up with this. Is that okay? Anybody still have questions on that? All right, so let's find the total amount of interest we paid for the car. So I would say, well, I'm paying $284.51 for 36 every month for 36 months. So I'm going to multiply them together. $284.51 equal payments for 36 payments. So it comes out to a total of $10,242.36. So that's how much I'm actually paying. And then I just subtract the actual cost of the car, and I'll get how much I spent on interest. $742.36. So that's the cost of financing the car. For the convenience of not having to come up with $9,500 all at once, you end up having to pay an extra $742. Yeah, if you haven't ever looked into it, a 30-year mortgage, for a $200,000 house, you end up paying like $600,000 or something for that $200,000 house. Yeah. It's pretty crazy. Okay, so it's a little clearer what formulas go with what kinds of problems. Okay, good. Good. Let's look at the snowflakes. We've got 10 minutes left, 12 minutes. Oh, and I didn't do the credit card problem, but we did that in class like last week. So, okay. So let's assume that the seed triangle of the Koch snowflake has sides of length 6. So I'm just going to draw it. Before I start trying to deal with this table, I'm going to draw what they're describing to me. Seed triangle of the Koch snowflake. So this should be shaded. And it has sides of length 6. Okay. So we're going to let M denote the number of sides, L the length of each side, and P the perimeter of the snowflake. So at the start, I just drew the seed, right? How many sides does it have? 3. So that's where the 3 comes from. The length of each side, they told me in the problem, was 6. And then my perimeter would be 3 times 6, 18. All right, and then for step 1, I'm going to draw it to help me figure this out. So I got to break each side into thirds and then put an equilateral triangle on the middle third. Okay, so because of the way I constructed this thing, what's the length of each side? 2, yeah, because the whole side of my seed was 6, and I broke it into thirds, right? So this would have to be 2 and 2 and 2 and 2. Right? So each side has length 2. How many sides are there? 12. Yep, we just go around and count them. We've got 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12 sides. So then my perimeter is 12 times 2, or 24. All right, so now, if you haven't observed a pattern or don't remember the pattern from the last time you did a problem like this, draw the next step. Draw step 2. So on each existing side, on the middle third, put an equilateral triangle. Okay, so now I need to count how many sides I have. So just go around and count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 45, 46, 47, 48. So now I have 48 sides to my snowflake. And what's the length of each side? 0.6 or 2/3, yeah, because at my previous step, the side length was 2, and then I broke that into thirds, right? And so 1/3 of 2 is 2/3. So I have 2/3 is the length of each side, and then multiply 48 times 2/3 to get the perimeter. So that would be 96 thirds, yeah. Which I think $32, yeah. Okay, so now, once you've drawn the seed, step 1, step 2, so you've drawn this out 3 times, and you have 3 sets of numbers to look at, hopefully we can find a pattern in these numbers so we don't have to keep drawing this. Though you could, right? If you don't see a pattern, we could draw this again and count. But it appears that the number of what's happening to the number of sides at each step. Multiplied by 4. Yeah, 3 times 4 is 12. 12 times 4 is 48. So we just continue to follow that pattern. We get 48 times 4, 192. Times 4, 768. And if I wanted to get step 40, you have to kind of reason out how you would get there. I could just keep multiplying by 4 and like keep track of my fingers how many times I've done it, right? And I have to do it 40 times. Or I could say, well, start at 3 and multiply by 4 40 times. And to multiply by 4 40 times, that's the same as multiplying by 4 to the 40th. Which is a giant number, so I might as well just write 3 times 4 to the 40th. And not do it out. Okay, now when I look at the length of each side, 6, 2, 2/3, I'm calculating those numbers by taking the previous side and dividing it by 3. So 2/3 or multiplying by 1/3, whichever way you want to think of it. What's 2/3? What's a third of 2/3? Close. 2/9. Yeah. Yeah, so when I want to take 1/3 of 2/3, so it's 1/3 times 2/3. And when you multiply fractions, you multiply the tops and the bottoms. So 1 times 2 is 2, 3 times 3 is 9. 2/9. And then I'm going to multiply 2/9 by 1/3, and I get 2/27. And then to get this 40th, I would say, well, start with 6 and multiply it by 1/3 40 times. So times 1/3 to the 40th. And that's a teeny, teeny, teeny tiny number, so I'm actually just going to write 6 times 1/3 to the 40th. And my perimeters are the number of sides times the length of each side. So 192 times 2/9, 42.67. You could write it like that. That would be totally fine. Many of you are finding in my math lab that you're supposed to put in an exact fraction. So if you have at least a scientific calculator and not just a little keychain calculator or something, you can make it change numbers to a fraction for you. The calculator won't? Oh, maybe it's too, maybe the numbers are too big or something. Okay, so we'll have to just multiply it by hand then. Like, so if I want to do 192 times 2/9, 192 over 1 times 2/9, and I could put this, just do it by hand, just multiply the tops, 192 times 2, 384, and 1 times 9 is 9. So you get 384 ninths. Oh, and you have to reduce it. Yeah, okay, so I don't think that that's reducible. The 384 and, oh, okay. And then for step 4, I would do 768 over 1 times 2/27. And to multiply fractions, you just multiply across. And I should see, does 768 and 27 have any numbers, common factors that I can cancel before I multiply? No. 768 divided by 9? No. 256. Okay, so 3 goes into 27 9 times, and it goes into 768 256 times. It's just handy to reduce before you multiply. So we do 256 times 2, we get 512. 1 times 9 is 9. You might also notice that there's a pattern in here of times 4/3. Which kind of makes sense because m is times 4 and l is times 1/3, and then you multiply them together. 4 times 1/3 is 4/3. All right, so then this last one, we need to multiply these two. So the 3 times the 6 would give me 18. 4 times 1/3 would give me 4/3. 40 to the 40th. Which one? 384 over 9? Does it reduce? I don't know. Yeah, you could reduce that to 128 over 3. You didn't reduce, okay.